Hi guys, welcome to another episode of Mr. Brown's Secondary Science. Today we are going to look at changes of states in materials, and we're going to do this by using temperature time graphs. You will often find that you are given a graph like this and you'll need to understand what it's showing you. You'll need to understand what states of matter are happening at each part, and you'll need to know what temperatures we're dealing with on here as well. So we will understand what they show, we'll know how to read temperature data from this type of graph, and we'll be able to work out what state a substance will be when we're given its temperature through using one of these. So first of all, on this graph you can see we have two axes as always. On our x-axis we have time in seconds, and on our temperature axis we are measuring it in degrees Celsius. Now, as time goes along, we are adding something to a material to make this change in temperature happen. We are adding energy. So energy is being added to the particles in that substance. Energy is being added to the particles over time. This is causing that temperature increase. This is causing this line on the graph to increase in time. And you can see there are times when it steadily increases, then goes flat, whilst energy is still being added to it, then increase and going flat again. Now, first of all, the first section as the temperature steadily increases, this is where a material is solid, in its solid state. The next phase where we are going through that steady increase, that is where the material is a liquid. And the final phase here, this is where the material is a gas, where it has its most energy. So the state of matter with the least energy is solid, the next one is liquid, and the next one is gas. Now, as we go from a solid to a liquid, that is a certain point, a certain temperature where that happens in every material. That is the melting point. The melting point. So if we had ice going to water, it melts at that temperature, which we have here on the temperature axis. And then when we go from liquid to gas, that is our boiling point. Boiling point. And again, it can be measured here on the temperature axis. So that's great. This is a graph that shows the changes of states in a material as you add energy to the particles and the temperature goes up. But what does this mean for different materials? Well, lead. If we look at lead, we can see that its melting point 327 degrees Celsius. It's really high, and its boiling point is even higher, 1774 degrees Celsius. Oxygen, now it's a non-metal, whereas lead is a metal, its melting point's really, really low, really cold, minus 219 degrees C, whereas the boiling point, not quite as low, but still very low, it is minus 183 degrees C. Now let's compare that to water, which we are all hopefully familiar with. Water melts at 0 degrees C, going from ice to liquid. And then its boiling point at 100 degrees C is where we go from liquid water to steam, its gas form. So, as comparison, we can put lead here. Its melting point 327 degrees C. That corresponds here on the graph. Its boiling point 1774 degrees C. Corresponding here. We can do the same now for oxygen. We know its boiling point is minus 219, so we'll add that in, and we know that its boiling point is minus 183 degrees C. Water, we know it melts at 0 degrees C, and it will boil at 100 degrees C. So it doesn't matter which material you are dealing with, they will all follow this pattern, but the temperatures at the melting point and the boiling point will be different for the material you are being asked about. Now, you will often have this question. Right, it is 75 degrees centigrade, or something similar. What is the state of matter of these materials at that temperature? Using something like this, it is very, very easy to find that out. So, for lead, 75 degrees C, that is colder than 1774 degrees C, and it's colder again than 327. So we know that at 75 degrees C, which is less than both of these, lead is going to be a solid. Next up, oxygen at 75 degrees C. Now 75 degrees C is definitely a bigger number than minus 219, and it's a bigger number than minus 183. So we know that at 75 degrees is bigger than the boiling point. Oxygen at 75 degrees is going to be a gas. And finally, water, 75 degrees C, bigger number than 0. Is it bigger than 100? It is not. So it's going to be between the boiling point and the melting point, which means that water at 75 degrees C is a liquid. Okay guys, so we have gone over what this kind of graph means, what a time temperature graph means in terms of states of matter. Solid comes first. Then we have the melting point here. As energy is added, the temperature doesn't change, but then eventually it gets to the next state of matter, which is liquid. More energy is added, temperature goes up, but when it hits the boiling point, the temperature remains the same until all particles now have enough energy to be gas. From here we know that the boiling points and the melting points, they are going to be different for different materials. There will be different temperatures depending on the material you have, and we can use that information to help us find which state of matter these materials are going to be at a given temperature. That was another episode of Mr. Brown's Secondary Science. If there are any questions or comments, please put them in the comments below. Remember, if there's anything that you would like me to help you with, please do let me know as well. Thank you very much, everyone. See you next time.